Okay.
Sir, group number 1 is presenting. Group number 1 is presenting.
Okay, sir.
Yes, sir. Yes, sir. Group one is present.
Sir.
Okay, sir. Carry on. Carry on.
We are here, sir. Continue, sir.
Good afternoon, everybody. In this mathematical modeling,
Sir, I'm here.
Please take care of this.
Okay, sir.
Madam, please.
yeah. Good afternoon, everybody. I'm Srivali from KV Gachibowli and from Group 1. And in this, we have taken the present in this pandemic situation. How we know that in KVS we are observing absenteeism. So we have conducted a survey, like a randomly collected students' attendance data over 15 days indicated that about 20 out of 50 students are not attending the online classes. As the percentage of absentees is very much on the higher side, the school authorities must take necessary measures to improve the attendance. Data also indicates the 4 major reasons. We have collected the data. So, and we collected what are the 4 major reasons for the absenteeism of the students. That is, students' family is below poverty line and the limited connectivity. That means only either of the parents must be, they are having only one phone. So in the present, the parent is present, they could attend. If not, the child objects that limited connectivity and network issues in the power cut, anyhow daily we are facing. So suggest a solution using the mathematical description and formulation to this problem. Actually, I have taken the real life situation that presently we are facing. The solutions. First, defining the problems. What is the problem is to identify the reason for absenteeism. And we have to provide a solution. Understanding the data indicated the absenteeism is around 40%. When we underwent the finding the survey, there are mainly four reasons for absenteeism. That is about 10.
Excuse me, madam. You can show that slide, madam. Is the slide or PPT, madam? Is PPT? Is it PPT, madam?
No, sir.
Slide. We cannot.
Make a slideshow, madam.
No, it is Word document, sir.
It's a Word document.
It's Word.
One side is coming.
Okay. Continue, madam. Continue.
Continue, madam. Okay.
Please, I request to other to please mute your mic. Yes, madam. Carry on, madam.
Okay. When we underwent the findings of the survey, there are mainly 4 reasons for the absenteeism. About 10 students are BPL and some are facing the problem with the scarcity of the resources. That means either father or mother going for work or siblings also to attend the classes, especially those who are in higher classes like 10th and 12th students, and network issues and the power cut. So, and the reasons, how many BPL students are 10 and the limited connectivity facing, 6 children are facing the limited connectivity problems and 2 children are facing the network issues and power cut is 2. The same thing is shown in the bar graph. And what are the possible solutions for the defined problem? So now we have come for the solutions. So we underwent a survey and we find some solutions for these problems. The BPL students, these students may be allowed to the school to attend online classes, one choice. Another one, the printed worksheets can be provided. This would be address the infrastructural inadequacies of the BPL families and facilitate learning. So that the BPL families, children, they may not be having the resources at home. So they might be allowed to, to the school. For example, in KV Gachibowli, one child, actually he is in 12th standard, he is from BPL family. So he has taken the permission of principal sir and he is attending the classes. So that is one solution. And children, those who are away, and for them, the printed worksheets can be provided. And the children has the limited connectivity. This is beyond the control of the school administration. And the teachers can record the lessons and upload the same either in the Google Classroom or in the WhatsApp group or to facilitate the children to access a suitable time. Even our school find out one more solution. That is Kumar Swami sir. He is recording all the lessons and he is uploading the videos, and entire India almost and abroad also they are using the videos. And the network issues and the power cut, this is also beyond the circular influence of the school authorities. All the classroom activities can be recorded and uploaded in the Google Classroom or in the WhatsApp. for the students to access when there is power cut and connectivity issues. Even this, yesterday we learned in the class up to record, so we can do the same, we can implement the same practice, and so that the children can use later. This is the interpretation. That is, first step is to identify the reason for the students being absent in the online classes. The first step is to identify the problem, real life problem. So we identify many children are absent for the classes. For the second one, we have to mathematization. For that, the four main reasons are identified in the above problem. The possible solutions were suggested based on the observation through the deliberations with the peer groups. And this will improve the attendance. For the implementation of the proposed solutions, a graphical representation and estimated outcomes is given below. As we implemented the same, and we observed that the absenteeism has been reduced. Even in the first days, 10 students were absent earlier, and as we allowing them to the school or by providing the worksheets, now only 4 children are getting absent, even here also. And we observed that if we provide, if we have taken these steps, the absenteeism will be definitely reduced. I think this is our project. Simulation work we did. Thank you for giving me the opportunity. Thank you.
Thank you, madam. Wonderful presentation.
Stop sharing, madam.
And
Okay.
example is also very good. Nice, with related to real life problem. Excellent, madam. Presentation is very good. Now, any other one is from.
Sir, let me say one thing, sir. Let me say one thing.
Yes,
Sir, it is really excellent, sir. Really excellent. I think that a very real situation she has taken, and she is proceeded all the steps followed and mathematics. Excellent, madam. Very nice.
Thank you very much, sir. Sir, this is a group effort also, sir. And
Yeah.
I'm not a techno savvy. All my group.
Great goes to the group, madam. Great goes to the group.
Okay.
Thank you,
Any, next, any other is there from group number 1?
Group 2, sir. Group 2 will present after this.
Yes, madam. Vandana, madam. Carry on.
Krishna, sir.
Actually, one individual work, best individual work, and one
Krishna, sir, will be presenting.
anyone is presenting from group 1?
Yeah, Krishna.
Madam, wait, madam. Wait.
Yeah.
Group 2, sir. Group 2. Madam, Vandana, madam. Go on, please.
This is group 2 or group 1?
Group 2, sir.
Okay, continue.
Group to carry on, sir.
Yeah, very good evening to all the resource persons, program coordinator, and participant teachers.
Other
So
member,
today
please. Other
Yeah,
member,
I
please
think all
mute your
members
mic.
are present. Yeah.
Other member, please mute your mic. Your sound is echoing.
Okay. So as we were given the task of mathematical modeling, we had to use mathematical modeling to solve. Krishna sir, you also mute your mic. We had to use mathematical modeling to solve any real life problem. So we had to
Please mute,
connect our mathematics
Krishna sir, mute.
to the problems of our
Please mute your mic, sir. Lal Krishna sir.
environment and come up with a solution using some mathematical formula and things. Yeah. So the topic that we have taken is how to control and overcome the COVID-19 pandemic situation across the globe. This is a study based on the data in the month of June. Data has been collected from reliable websites in the month of June, from the month of June. So step 1 is identifying the problem. So this is the problem. Step 2 was mathematical description and formulation. So we had to represent it in a mathematical form. So we have connected it to the statistical analysis so that data can be represented in a tabular form. And after that, we can do some pictorial representation based on the data. We can do some calculations also based on the formula for percentages and rates. And then we can, just a minute, sir, pause it there. So we have taken three things here: number of people affected, number of people recovered, and number of people died. These are the three main fields we have covered. And as a sample, we have taken 10 countries, 10 major countries across the globe. And that is the sample data according to which the whole inference will be based. So this is a sampling. These 10 countries are taken: India, UK, Russia, Germany, Spain, Mexico, Iran, Italy, and Peru. This is the data, and it is rounded off: number of people affected, number of people recovered, and number of people died. So this is the data for all the 10 countries. This file is in Word format only. Then the step 4 was solving the mathematical problem. So we have used two formula here. First is for calculating the recovery rate. Formula is number of people recovered in a particular country upon number of people affected in that country multiplied with 100. So R1, R2, R3, like that we have calculated 10 values. Similarly, now we are calculating the death rates. The formula again is, it has to be D. D equals to number of people died upon number of people affected into 100. So again the 10 countries, and now we have tabularized. It was D1, D2, D3, D4, D10, 10 data, 10 calculations we made there. We filled it in this table. Again, the same countries: India, UK, Russia, Germany, Spain, Mexico, France, Italy, Iran, and Peru. So these are the number of people affected. This is the recovery rates. Again, it has been rounded off to two places. And these are the death rates. Now we can observe from the table where the recovery rates are high, where the death rates are low. Those are the countries which are faring the best in this situation. That means the measures taken by these countries are better than all the other countries where recovery rate is lower and death rate is higher. Yes, sir. Next. So these are the things we have taken. We have taken bar graphs. We have drawn bar graphs for the affected people, number of people affected, then the number of people recovered, and number of people died. It is a comparative bar graph. It is a triple bar graph. You can see the blue bars are showing the people affected in that country. Then red shows the recovered, and the green one shows the people died. So we can do a comparative study based on this bar graph. And then suitable measures can be suggested or can be taken. Now, yeah, these are the individual bar graphs for the recovery rate of all the major 5 countries. This is individual bar graph. And we are using this maths is fun. We have filled in the fields, title, x-axis and y-axis fields. We have put in the values and the labels as we were told in the morning demo. And we can convert it to other graphs also. This is COVID recovery rate. This is kind of frequency polygon or the line graph. And this is the pie chart, so that it can be compared that in which of the countries the conditions are most unfavorable. There more medical aid or more funds or more strategies are to be taken, and those who are having a better situation can help those countries requiring these aids. So all the pictorial representations that we have in statistics are being used here to do the comparative analysis. And just one more thing. Krishna sir, I'll just present that one more frequency polygon now. You can stop your presentation, sir.
It is not there, madam.
Yeah, I'll present, sir. I'll present.
You can claim it.
So this was the same file, only one more sheet is added here. This was the last table, and I have just highlighted the countries which are having highest recovery rate and the lowest recovery rate. Similarly, highest death rate and lowest death rate, which is Russia, Germany. So interpretation, step 4 was interpreting the solution, whether the solution has been effective or not. So we observed that Germany and Russia have higher recovery rates and lower death rates. Thus, UN and the health ministries of France and Iran with high death rate and low recovery rates can take directive measures from these countries to improve conditions in their own countries. Medical aid can be provided to needy countries. PPE kits and preventive drugs, immunity boosters, effective strategies can be shared from more efficient countries to the ones requiring it, and inference is that the given problem is solved using the mathematical modeling. And so this is the model. And one more frequency polygon I prepared. This is only for the recovery rate for the same data. Again, we are using Mathsys1 in this. So this is the title, recovery rate. X-axis is showing all the countries. Y-axis is showing the recovery rates. I have rounded it off to whole numbers, integral parts only. It was in decimals, the values, real values. And the frequency polygon is drawn like this. So yeah, that is all from group 2.
Okay, nice example, madam. Very good and excellent presentation. Satyanarayana sir.
Yes, madam, it's very nice, madam. Here, can I say what are learning outcomes? Can I say at least one learning outcome from this modeling? Can anybody else suggest what learning outcome by this modeling? Very nice example, madam. Very nice.
So learning outcome is as such that the country which is showing the best performance was more prepared to face such a natural calamity, and that strategy or those things can be shared or used by others.
Suresh sir.
So
And
that
one
is
learning outcome that we have learned, maths is fun.
What you told correct only, madam. What you told is the learning outcome. From that, what they will understand it. Why some countries having a just death rate, we have maximum death rate. So student understand it. The maximum death rate. That's only going to put in the it is a learning outcome only. Okay, madam. That is you will understand it. You will infer it. Then he will draw inferences from that. Why it is so. So they will study about that why it is happened so in each country. So that is the learning outcome, madam. It's very beautiful only. Excellent, madam. Nice.
Thank you.
Any other presentation from the same group? Suresh sir, please mute your mic. Suresh sir. Suresh sir.
here in that learning outcome I want to tell.
Okay.
By seeing that analysis, some children, if not all, they will understand the intensity of spread of COVID in different parts of the world, and also the steps taken, as madam told nicely. One learning outcome is here intensity is more, here spread of COVID is more, and here it is less, death rate is more, like that they will come to know.
Right, sir. Accepted. Nicely, sir. Okay.
It's one of the learning outcomes, sir. Very nice, sir. Suresh sir, very nice.
Okay. Any other presentation is there from the same group? Group leader. Okay. So then we'll move towards group number 3.
We are sending group.
Group 2 also has more, but actually you told one, so.
No, madam. I told one best individual. and another model I made.
Okay. It is there. They have shared in the WhatsApp group.
Okay, no problem. Let's move towards group number 3. Group number 3, who's going to present?
Yes, sir.
Okay, sir, please, sir.
Good evening, all. From group number 3, here,
Sir, you can,
you have given two
by
parts.
presenting, please give your introduction only so that everyone will know.
Okay, sir. So, from our group, Ankita Singh Madam will present part 1.
Good evening, sir. Good evening to all. Now, I'm going to share that I have prepared one PDF, that PowerPoint. Okay, that is based on the square. The topic which I have taken here, that is area of a square. That is area of a square, that is side into side. I have taken one question from the class 7. That is, a path 5 meter wide runs alongside inside a square park of side 100 meter. Find the area of park. That one thing that we have to find, that is area of park, and also we have to find out the cost of cementing that park, and at the rate is also given, that is rupees 250 per 10 meters square. So first of all, the first step, which is the understanding the problem, which is the figure is given as you can see here, that the ABCD is the square part and the side which it is having, that is 100 meter each. And the shaded portion, as you can see here, this is for the understanding of the problem. That is, shaded portion is 5 meter wide, which is runs inside the square part. Okay, and PQRS is the square part excluding part. First of all, we have to after that we have to find out the area of PQRS, which is excluding the path of 5 meter wide. The problem is that first of all we have to find the area of the part which is shaded in the figure, and after that we have to find the total cost of cementing. We have to find out the total cost of cementing this part, and the rate is given to you, that is rupees 250 per 10 meters square. The next step is that mathematical description and the formulation. The things what we are going here, as we can see in the first slide, that we are going to use area of square, that is side into side. So first of all, we are going to use area of square, that is area of a square part ABCD side into side. After that, we have to find out the area, the length of the PQ, which is excluded the length of 5 meter wide. So that is for finding the area of a path, we will subtract area of square PQRS from the area of square ABCD. Then after that, when we are going to find out the shaded portion, the total shaded portion in this figure, then we have to area of path is equals to area of ABCD minus area of PQRS. That's one. After finding the total path area, we have to cementing also. We have to find out the total cost of cementing. So for that, first of all, in our question, it is given for 250 per 10 square meters. So first of all, we have to find out for the 1 meter square, that is equals to 250 upon 10. After finding this one, so we are going to find total cost for cementing the area, path. That is area of path multiply cost of cementing 1 square meter. After that, the third step, which is there, solving the mathematical problem. Okay, how we are going to solve, how the learners can solve this problem, that is side of the square part, that is 100 meters. So we are going to apply here area of square part, that is ABCD, is equals to side into side, that is 100 multiply 100 meter square, that is over 10,000 meters square. After that, we are going to excluding the wide, that is PQRS. For finding the area of PQRS, we are going to find out first of all side, that is side of the path excluding path is equals to 100 minus 5 plus 5 meter, that is 90 meter. And again we are going to find out the area, again we are going to apply the area of the square, that is PQRS, 90 multiplied by 90, that is 81,000. The final, which is the question asking, in the question that is area of path is equals to area of ABCD minus area of PQRS. So the area of ABCD is 10,000 minus 8,100. So the total area of path we got here, that is 19 meters square. After that, the cost of cementing also they are asking, that is rupees 250 per 10 meters square. So that cost of cementing 1 meter square is equals to 250 upon 10. Now the total cost of cementing 100 meters square, that is the area of the path, that is 250 upon 100 multiplied by 900. So the total cost of cementing the path only, that is rupees 47,500. Interpreting the mathematical problem, that is hence we have area of the path 1900 meters square and total cost of cementing the path, that is 47,500. Validating the models, we go back to the original situation and see if the result of the mathematical work makes sense. If so, we use the model until new information become available or assumption changes. The learning outcome, which we come to know here, that first of all, the learners learn concept of square. The learners compute and find the area of a square. And the main thing is the learner applies this mathematical concept in the real life. Thank you, sir. That's all.
Okay, nice example, madam.
Thank you, sir.
Presented.
Thank you, sir.
Sir, my name, sir. Really, it is nice example, madam. You have presented a very stepwise.
Thank you, sir.
Ramnarayan, sir. Ramnarayan, sir. Sir, I will ask one question. Ramnarayan, sir.
Yes.
Can we refine this one? Instead of same question we have from textbook, no? Can we refine it? Some more in the same problem only. Some more we can put in the real problem situation. Can we any teacher can give suggestion? Can you refine it?
Yes, sir. Actually, sir has given two topics, sir. Number one is taking math topic and applying into real world.
Yes.
So real world example she has taken. And another one, sir has given real life problem that I am going to present. Okay.
No, this one also we can you refine the same thing which is given in the textbook? Can we refine it instead of cementing road? So can we have some more? So that the student will have the problem is different. I think we can think about that. Can anybody suggest like that?
Satyanarayan, sir.
Yes, sir.
So a park is there in one layout. So in the for a walking track.
So laying grass we can
walking
use.
Track cementing is required.
Yes.
So that can be connected to this problem to refine.
Yes, sir. This is one suggestion only. So that you can refine the problem. Grass can be laid and part of the
grass can be laid.
Path inside and path outside. Inside path and outside path.
Sometimes benches can also arrange it. So that area we can take it. So many we can refine the problem.
Yes.
I think everything is followed. But we follow everything very clearly. Very nice.
Okay, sir. Now one more is there.
Yes, sir.
Yes, sir. Raman, one more is there.
Yes, sir.
Please, sir.
Okay, sir. I am sharing.
Sir, what happened, sir? Ramnaran, sir.
Sir, Ramnan, sir. Ramanand sir.
Oh, he's left out. I think some
May,
okay.
network problem is there. Network problem is there.
Next group is ready.
Yes, sir.
Next group, who is going to present?
So from group 4, I am Anuja Sharma.
Okay, madam. Please carry on.
Yes, sir. Can you all see my presentation?
No, madam.
Just a minute.
Yes, madam.
Yeah. I hope now you all can see.
Yes, madam.
Yeah. So good evening, one and all. I am Anuja Sharma from group 4, and I'm presenting a mathematical modeling based on the concept of probability. We introduced probability to the children in class 7, and it is still higher grade also, till 12th also. But I'll restrict it to our knowledge, to my knowledge basically. So yeah, so I have formulated a problem, and the experiment conducted here is tossing of a coin. Now we have different cases when we toss a coin, like number of trials can be increased, tossing a coin 1 time or 2 times or 3 times and so on. I have taken the example of tossing of coin 4 times because then we can have more number of outcomes. Otherwise, this model can be applied to any number of trials. So I am starting with step 1. Step 1 is understanding the problem. Now, when we toss a coin 4 times, in this case I am considering a number of trial equal to 4. So a lot of combinations occur. So the basic problem here is to find out which combination will have more chances of showing up when a fair coin is tossed 4 times. I hope the problem is clear to everyone. Step 2, the mathematical description of the problem. Now, to find out the probabilities of various possible combinations of heads and tails that show up when a coin is tossed 4 times, or we can say when 4 coins are tossed simultaneously. The outcomes are shown here with the help of a tree diagram. So when
Other
a coin is...
Other than that, please mute your mic.
So
Narendra sir.
Mute the mic, sir. Please unmute the mic.
So when a coin is tossed 4 times, the following outcomes appear on the rightmost column, you all can see, and it is also represented down. So a sample space of the outcomes is presented in front of you. Now we have to solve. This is the formulation of the problem using mathematical description. Now how to solve this problem? Now we'll now distribute the outcomes on the basis of number of heads below in the tabular form. So basically these are the total 16 outcomes, or 16 possibilities can occur when a coin is tossed 4 times, and I have written all the possibilities in the form of the sample space here. Now we need to find out which combination is occurring the most number of times when the experiment is conducted. If we see the outcomes, I'm counting the number of heads in this case. Either we can have maximum 4 heads, like in first case, or we can have 3 heads and 1 tail, or we can have a combination where we have 2 heads and 2 tails, or we can have a combination, if you look at the third row, 2 heads, 2 tails, then we can have an outcome in which there is only 1 head and 3 tails, like TTTH, right? And we can have an outcome in which there is no head, like T, 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 T. So I have represented that data in the form of table down. So we can have these following 5 cases when we are tossing the coin 4 times. Either we can have all the 4 heads coming up, or 3 heads, 1 tail is coming up, or 2 heads, 2 tails are coming up, or 1 head, 3 tails are coming up, and no head is coming up, right? Now we are finding the probability. There is only 1 case out of these 16 cases where all heads are turning up. So probability becomes 1 by 16. Now number of heads, if 3 number of heads are coming, in that we have only 4 cases. So probability becomes 4 by 16, which is 1 by 4. There are 6 cases in which 2 heads are coming up. So the probability becomes 6 by 16, which is 3 by 8. 4 cases in which 1 head is turning up, so 4 by 16. And there is only 1 case in which there is no head, which is T, 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 T. So probability becomes 1 by 16. So from this table, we see that the highest probability is of the case where we are getting 2 heads and 2 tails, like HHTT. So we observe that the chance of getting 2 heads is maximum, since its probability is 3 by 8, which is the highest out of all the other cases. So this is the solution of the problem. Interpreting the solution. So since the probability of getting the outcome with 2 heads is the highest, therefore we can guess this combination again and again. That means that we are going to get this combination in most of the chances, in most of the trials. Then validation of this model can be applied to any number of tosses. We can start from 1, then there is equal probability of head and tail. We can start from, then we can take the case of tossing of 2 coins, where we have sample space HH, HT, TH, TT. So there HT, TH, 1 head, 1 tail will have maximum probability of occurring, and so on. So we can actually generalize this model to n number of trials also. Thank you so much.
Just a minute, madam. Can you rotate your mobile?
Okay, sir. So was the presentation coming?
No.
All right.
Please rotate your mobile once.
Yes, sir. Yes, sir.
Actually, you have to go in this mode because the font was very small. So
actually, sir, it can. In laptop it cannot be maximized.
In mobile also, when you rotate,
okay.
In this form, it is good, very easy to see. Your example is very good, and the presentation is also very good. You have followed all the process of mathematical modeling. And Satyanarayana sir,
nice, nice, sir. Nicely. It's good.
Okay. Any other?
Okay, sir.
Is there for presenting, madam?
So one more ma'am is presenting, sir.
Yes, sir. Good evening, sir. Good evening, all teachers. Yeah. Myself Asha from KV number 2 Tirupati, and I'm representing the individual work done by the group member from group 4. I'm presenting my screen. Actually, I have taken the small section data handling from class 6 to class 8. Using Math is Fun software is there, that how we can teach the students effectively, that I have taken. Is my screen is visible?
Yes, madam. Carry on.
Yes, ma'am. Carry on, madam. Yes, carry on.
Oh. So, a small data handling problem related to blood donation day, and this is the problem here. There are 40 children in class 8A of school. In a health club program, there is a blood groups were identified and listed below. So these are the blood groups of the students, 40 students in a class, and they have listed in a raw data. And here, related to this data, they have asked some questions, 5 questions they are asked that is listed below. And here, students have to identify which is the easiest method to identify to answer all these questions. The questions are: how many children have O negative blood group, how many have B negative, how many have O positive, which blood type do the most number of children have, and which type do the least number of children have. In order to answer all these questions, we have first step what we have to do is we have to tabulate the data. So for that one, we have tabulated the data. Once we tabulated the data, children can easily answer for all these questions. Plus, if you use I have used here Math is one software, and using that one, I have represented it graphically. First one is a bar graph, with which we can easily identify that O positive is the common group or negative is the rarest one. Apart from all the other questions can also be easily answered. And if it is we are teaching for 8th class, where we are teaching them line graph and pie graph also, that also can be represented using the same data. And if we now the online teaching is going on, so we can show them directly how it will be converted from bar graph to line graph. So this is the bar graph of that particular data. And if it is line graph, the same data can be like this on. If it is in a dotted line, we can represent it like this. And if it is a pie graph, same data can be represented like this also. So like that, the children can easily relate how these graphs are interconnected also. That's all from and with using this one, they can do the conclusions for all these 5 questions.
Okay, nice example, madam, and nicely you have used that digital model. And now let us move toward the next group, group number 5. Who is going to represent? Who is going to present from group number 5?
Surya Prakash, sir.
Okay, sir.
Myself, Prakash, sir.
Yes, yes.
Hello.
Yeah, please, sir.
Good evening to all of you.
Please, keep your
From
mic.
TGT Notification. Hello, sir. So let me present.
Keep mic mute position. Lot of noise is coming. Yes, sir. Carry on, sir.
Yes, sir. Sir, is my screen visible, sir?
Carry on.
Yes, sir.
Yes, sir. Sir, this is the mathematical modeling of group work by group 5. See here I took one real life problem, sir. Where Sunny and Bunny are two good friends. One day they went to the market and bought wooden material to make 10 wooden toys as a part of their school group activity. If together they work, it will take 12 days to complete 10 toys. Sunny working alone can make 10 toys in 30 days. So how long would it take Bunny working alone to make 10 toys? So this is the problem I took, sir. Then here understanding the problem under mathematical modeling. In this problem, if both of them working together, they can complete 10 wooden toys in 10 days. If Sunny working alone, he can complete 10 wooden toys in 30 days. So we have to find in how many days Sunny working alone can make 10 wooden toys. So mathematical description and formalization. So let us represent the following variables as suppose if you took A is equal to Sunny's rate of making toys. So matlab number of toys made per day. B is equal to Bunny's rate of making toys. In 12 days, Sunny and Bunny together can make 10 wooden toys. So the equation is 12A plus 12B is equal to 10. Sunny working alone can make 10 toys in 30 days. So 30A is equal to 10. So that is A is equal to 1 by 3. So make this is equation number 2. And previous equation, that is equation 1. So we want to find that how in how many days Bunny working alone can make 10 wooden toys. So solving mathematical problem. Hello? Hello? Sir, can I continue? Hello?
Sir, please continue, sir.
Sir. From equation 1, we have, so this is problem solving. So 12A plus 12B is equal to 10. From equation 2, we have A is equal to 1 by 3. So substitute A is equal to 1 by 3 in equation 1. So we get B is equal to 1 by 2. So Bunny alone can make 10 toys in 10 to 20 days. In one day, he make half part of the toy, whereas Sunny will make 1/3 of a toy. So interpretation, Bunny working alone can make 10 toys in 20 days, and he is more capable of doing toys than Sunny, as he makes half part of a toy per day, and Sunny makes only 1/3 part of a toy per day. So here it is, we can validate this problem. We can solve any real life problem based on the given parameters using above mathematical relations. So this is the some outcomes in which we can learn from this concept. Students are able to form mathematical relations using algebraic concepts, able to solve algebraic equations using suitable methods, and able to draw suitable conclusions. So this is the one of the problem I took, sir. And second one is I took the mathematical topic trigonometry in a right triangle. So these are the two major concepts which we used in this modeling. Tan theta is equal to a by b, cos theta is equal to b by c according to this right angle triangle. So here I took one problem based on the above topic. Suppose a tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle 30° with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. Then find the height of the tree. So this is a real life problem based on the mathematical topic which I have chosen. So this can be solved based on the steps as we did in the classroom. So here it is the diagram. AB represent a tree and the AC represent the broken part, and the angle of elevation is 30°. So from figure the total height of so this is the formulation I did. I used the cos 30 and tan 30 as we discussed in the topic. And finally, I got the answer height of the tree AB plus AC is equal to 8√3. So here make use of learning outcomes, make use of tangents and quotient ratios to solve the problem and find the height of the tree correctly. And one more mathematical modeling I did, sir. So this is one using maths is fun. The number of students in a hostel speaking different languages is given below. Display the data in a pie chart. So here I made a pie chart for this. So here I took as Kumar sir explained today morning. So here I have chosen title speaking languages, and here it is language and number of students. So these are the values as per the PPT. 40, 12, 9, 7, 4. The languages labeled as Hindi, English, Marathi, Tamil, and Bengali. So finally, this is the pie chart which we obtained from the based on the figures given in the problem. Thank you, sir. Thank you very much.
Surya Prakash, sir. Very nice, sir. Excellent. You have taken modeling. You have taken. Very nice. Very nice. You have taken. And conversion method also you have taken, sir. Very good, sir.
Yes, sir.
Excellent. All the steps you have followed exactly followed. Really, it is excellent.
Thank you, sir. Thank you very much.
Okay, nice presentation. Now let us move toward the another group. Anyone or is presenting?
Sir, Pankaj sir is there. Pankaj sir from Group 5.
Okay,
yes, sir.
Pankaj sir.
Yes, sir. Good evening to all, sir. I am presenting the mathematical model related to linear expression from class 6 to 8, and on the higher classes also it can be used as a linear programming. So I am presenting here PPT. So I have taken the problem. Am I audible, sir?
Yes, 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 sir.
Yes. Sir, please continue, sir. Yes, sir.
Actually, I am using mobile. So I have taken the activity from daily life, calculation of profit. Sir, I have taken an example of furniture manufacturer produces two size of boxes, larger one and smaller one, that are used to make either a table or a chair. And a table, while making a table, he earns a profit of $3, and in chair he makes a profit of $5. So this is how. So there are two types of boxes, larger boxes and another one is smaller box. If he takes M smaller box and N larger blocks are produced by him, how many tables and chairs should the manufacturer make in order to obtain the greatest profit? So this is our question. So larger and smaller boxes. So this type of table and chair he will make. So in while making table, he will use one larger block and one smaller block, and in chair he will use one larger block and two smaller blocks. So the question is that what will be the maximum benefit? So this is the question: what will be the maximum benefit if he has 12 smaller boxes and or you can say blocks and 12 larger blocks? So here we can show mathematical description and formulation. So maximum benefit we can calculate here 3 into t. The variables we can use here because we don't know if we present this modeling to children, obviously we don't know the number of tables and the chairs. So we can take t and c as variable here. So this is how we can calculate maximum benefit. Solving the mathematical problem. So if we randomly we take the number of tables and chairs, this is based upon the hit and trial method only. So if we take 4 tables and 4 chairs, so we can calculate profit as shown here. So our profit in that case, if you take 4 tables and 4 chairs, so profit is $32. And if we take another example, like 6 tables and 3 chairs, so in that case, we can earn profit of $33. So we can take some more another examples also, like 5 chairs and according to 5, if we take 5 tables, then we'll calculate how many chairs we can use. So based upon that, these many cases we can see here. If we take so this is the table. We can interpret here how many tables and how many chairs we should take, so that according to those numbers we get profit. So this is how we can calculate here maximum benefit. We can see here that is $36. And how that benefit comes out, if we take 12 tables, if we manufacture 12 tables and 0 chairs, so all the benefit the manufacturer is taking from tables only, and he is producing 0 chairs. So maximum benefit he can take when he manufacture 12 tables and 0 chairs. So this is interpreting the problem. So next, validating the models, and now we'll go back to the real life situations again, and we'll check out whether it is possible for all the other values. So I have prepared 2 more tables taking 20 smaller blocks and 12 larger blocks, and in another table I have taken 25 smaller blocks and 12 larger blocks. So this is how we can see here. So in first case, we can see he can earn maximum $52 by making 4 tables and 8 chairs. In second, he can earn maximum benefit $60. That is produced by making 12 chairs and no table. So this is how we can validate this model. And learning outcome, and this is how the students learn to extend the concept of variable and constant to the linear expression further. Thank you, sir.
Okay, nice, sir.
Sir, it is nice, sir. Very nice.
And next, let us move towards the another group number 6. Who is going to present from group number 6?
Ikaram, sir.
Good evening. Yes, sir. Yes, sir.
Amazon madam. Amazon madam is ready. Amazon madam is presenting. Mrs. Ikaram sir also is having our problem. He also is going to present.
Okay, sir. Okay. Carry on. Carry on. Amazon madam, carry on.
Good evening, sir. Good evening to all of you.
Sir, my screen is visible.
Yes, madam.
Yes, madam. Yes, madam. Visible. Visible and audible.
Okay, thank you, sir. So, sir, I have taken a problem of finding actual dimensions of the playground. My problem that I have taken is there's a Roy whose drawing shows a layout of a playground whose dimensions are in the ratio 1:7 with the actual ground. So he has taken a drawing whose ratio with the actual ground is 1:7. Means if the drawing is 1, then the actual ground will be 7. If the length of the playground in the drawing is 8 inches, the length of the drawing is 8 inches and width is 5 inches, then what will be the dimensions of actual playground? So with the help of this model, this drawing, whose length and width is given, we will be finding the actual dimensions of the playground that we have to make. One more thing here, every 1 inch on drawing shows 10 feet of actual playground length. So now the length of the drawing is 8 inches and breadth is given as 5 inches. So we are given the ratio 1:7, means the drawing and the playground is 1:7, which means the length is 8 inches here. So if we take it as x, then the length of the playground will be 7 times of it. That will be 7 times x. So the length is here 8 inches and breadth is 5 inches. And the scale is also given here, 1 inch equals to 10 feet. So for solving this problem, we will be using this ratio between the drawing and the actual playground. Now, first we will be finding the length of the playground. Length of the drawing is 8 inches. So first we will be doing 7 times of 8, that will give 56. Now, the scale is given as 1 inch was equals to 10 feet. So we will be multiplying this with 10 also, that will give us 560 feet as length of the playground. Next, similarly for breadth of the drawing. Now the breadth was given 5 inches. So 5 into 7, 7 times of 5, 35 into 10, that will give us 350 feet. So from here, we came to the solution that the actual dimensions of the playground are 560 feet, that is our length, and 350 feet, that is the width of the playground. So from such models, we can go to the actual real problems we can find out. And learning outcomes, students will get to know about ratio and scale factor, and they will also learn about mensuration. Thank you. And validating from creating such drawings or models, we can actually go back to the real problem and estimate the solution, whether it is fitted in the situation or not. Thank you. Thank you, sir.
Okay.
Well done, madam. Well done, madam. All the steps.
Example. Now, next taker answer.
Yes, sir. Good evening, participants, master parents, and resource persons. My name is Tikaram Mendevar. I am from Kendriya Vidyalaya Rajampalli, and today I am going to present a presentation on mathematics modeling. Sir, I have taken a topic that purchase of a dream car. So first step is understanding the problem. I hope my voice is audible, sir, and my screen is visible to everybody.
Yes, sir. Yes, sir. Carry on.
Yes, sir. Yes, sir.
Yes, sir. So I have taken a real life problem which is stick to the real life situation, sir. Samarth want to purchase a premium hatchback Tata Altroz. The on-road price of the top model and the petrol variant of the car is 8 lakh rupees. Presently, he is having 5 lakh rupees to pay as the down payment. For rest of the money, he is decided to borrow the loan from a bank. Bank lending the loan at the rate of 8% per annum calculated annually on simple interest. He cannot pay monthly installment exceeding 20,000. So what will be his best EMI, that is equated monthly installment, for the returning the incurred amount to the bank? Second is mathematic description and formulation. So I fit that in the formula and find out the rate of interest, simple interest. And we can see that the money required for Samarth is 8 lakh rupees, while he is having 5 lakh rupees with his own, and he need to take a loan of 3 lakh rupees from the bank. So I have formed three equations, A, B, and C. And in the last, I find that monthly EMI for 4 years will be the principal plus interest divided by 48, that is number of months. For he is taken for 48 month means 4 year. Third, solving the mathematical problem. So I solve that by using the simple interest formula, and I get that he is getting the EMI of rupees 8,250 rupees for 48 months. Fourth step, interpreting the solution. Since the installment is rupees 8,250 for 48 months, he can also choose the installment of rupees 11,000 for 36 months, or the installment of rupees 16,500 for 24 months. All these three installments are getting fit in his budget. Step 5, validation of the model. After observing the solution of the problem, we can go back to the problem and estimate that the solution is getting fit in the situation which I were asking. If then we can validate the solution for the given problem. So this is it, sir.
Okay, nice example, sir. Good presentation. Now, anyone wants to present? From group 1, I think only one presentation was there. Or
Ramanan sir want to present, it seems. Ramanan sir wants to present. Ramanan sir, are you there, sir?
Present, already it is 5:40, or shall I keep in the web, WhatsApp group?
no, sir. You can upload in that in Google form. So can we now wind up the session?
Yes, sir, because it is too late. If you want, I will present now.
If all wish, then I don't have any problem.
Ramanan sir, present how much time it takes? Maximum 5 minutes.
5 minutes.
Okay, sir.
Carry on, Ramanan sir.
Because already you prepared, you spent some time so that we also come to know what you prepared.
Okay, sir. Sir.
Sir.
Is it visible, sir?
Yes, sir.
Okay. Sir, I have taken a real life problem. We see different advertisements to attract customers by shopkeepers. So, customers are confused where to buy. So, during festive season, the shopkeepers attract customers with variety of discount offers. In the Inorbit Mall shopping complex, there are 4 ready-made garment stores offering different discounts as follows. Problem. Divya wants to buy 120 dresses for donating at an orphanage on the occasion of Christmas. How can we suggest to choose the right shop which is giving best offers? In all the shops, all required dresses and brands are available. All the shops are offering discount on MRP. So shop A is offering buy 2 and get 1 free. Shop B, buy 3 and get 2 free. Shop C, buy 5 and get 3 free. And shop D is giving double discount, 10% and then 33%. So we have to see which shop she has to buy using our mathematical concepts. So representing in mathematical form using ratio and discount. A number of dresses required are 120. Let us consider 500 rupees for each dress. Just we are taking. Shop A, buy 2 and get 3 free. So if she buys 80 dresses, then she will get 120 dresses. That's why fraction is 2 by 3. And we have to find cost of 80 dresses only. So it has come around 40,000. Then shop B, in the same manner, if we calculate, it is 36,000. And then if we go for shop C, and in the same manner, we are getting for 37,500. And shop D, double discount, people are getting confused by seeing this. 10 plus 33%, they will think that 43% discount they are getting. So how the shopkeeper will calculate? First, he will find the MRP and 60,000, then 10% discount, subtracts it, 54,000. On that, again, he will take 33% discount. So we will get for 36,180 rupees. And next, so amounts to be paid by her in different shops. If she go for shop A, she has to pay 40,000 like this. So hence we can suggest her to buy from shop B. Learning outcomes. Converting real life situation into simple mathematical forms, applying mathematical concepts, solving problem by using mathematical formulae, arriving at suitable solution, and applying in other similar situations. So when same situations are there, we can apply this. Thank you, sir.
Very nice, sir. Ramayana, sir. Very nice, sir. Nicely presented, sir. And the real life problem you have taken, sir. Very good, sir.
Short and sweet. Okay, sir.
Yes.
Kumar sir, please. All presentations are very nice. All are presented in excellent way, and I request all to upload in that Google form. It will be available till late night and even tomorrow also. Then after that, I will share the link to Brahmaya sir. He will compile all the that individual work. If anything else to say, anybody want to say something?
Sir, let me speak. Let me speak, sir.
Okay, fine, sir.
So really, sir, we are very happy with our reason, sir. We have got very good name that Master teacher sir. Here we have, by seeing all your presentations, really moved, sir. Very nice presentation you have had. The mathematical model really you understood and you presented very nicely, sir. I am thankful to every participant who presented here, and thankful to every participant who are here in this group. Really excellent, sir. We are happy from all other reasons we have taken, but in other reason we are feeling very happy here. Presentations are very nice presentations. Really, it's, I'm very much thankful to all of you. Thank you, sir.
Sir, anyone want to any doubts or any finally? Any participants? Right. So, Kumar sir.
Tomorrow is holiday.
Tomorrow is holiday.
So you can have one day rest.
Okay, sir. Kumar sir,
No, sir, we can have.
Let me conclude.
Sir, any participant, any feedback from participants? One or two.
Participants, any feedback? Ramnan sir.
Good. Everything good.
All is well.
Sir, excellent, sir. Excellent.
All is
well. We are learning so much, sir.
See, we are seeing if you are teaching 9th class, 10th class, 11th class, 12th class, in mathematics textbooks, there are two topics. One is this mathematical modeling. So generally it was not, because star mark is there, it was not for the examination point of view, everyone leaves. Even though we are teaching from last 10 years, 20 years. Now, because of this CBL, the JIT gave the training for the research persons, and they are able to implement it because at last, even though the NCERT or CBSE are not serious about it. So it is very nice training presentation today by the resource persons and the participants. We are thanking to all for your cooperation and enlightening with mathematical modeling, giving some inputs regarding this. And the Satyanarayana are the way of presenting stepwise. So finally I understood in simple way mathematical modeling. I am teaching 10th class, teaching field from last 20 years. So heights and distance problems can also be fit in mathematical modeling. That I learned from Satyanarayana sir.
Thank you, sir.
So I thought mathematical modeling it is from another planet. It is not our out of syllabus like that we thought. Finally, you simplified it like simple thing. Heights and distance also comes into mathematical modeling.
Yeah.
Very
Sir,
nice.
it is in a real sir.
Yes, sir. Yes, sir. Earlier, what I know, because CBSE said it is out of syllabus, we didn't go through that. Majority not gone.
Here, Suryaprakash was trained very nicely, sir. This is the one thing.
Yes, yes, that's why. But you say you may explain it in very lucid manner.
Yeah.
Thank you. Into 5 steps and fitted into mathematical modeling. It is a simple and super. Thank you, sir. Thank you very much. It's a wonderful.
Very intelligently they presented, sir. Very intelligently they presented.
Yes, yes. You presented. We don't know the persons behind you, but you are the person in front of us. We learned you from the very simple and easy concept. Thank you, sir. We will go through the textbooks once again. 9th, 10th, 11th, 12th. Again, we will go through the textbooks and try to explore what is mathematical modeling once again. Even though we have this in post-graduation mathematical modeling. Right. Thank you, sir. Thank you very much. Thank you to all the thanks to all the participants. And Monday, Group 3 members present today's proceedings on Monday.
Thank you, sir.
Thank you, sir. Whatever the presentations are there, please post in the WhatsApp group so that others can see that. And same thing we can compile. Thank you, one and all. Thank you, Kumar sir, for your efforts, and Satyanarayana sir.
Thank you, sir. Thank you.
Thank you, sir.